I am all for being intentional about our choices in technology. And as you know, all technologies is perfect. They have advantages and disadvantages. And I think as developers, it's important to be able to not only use those technologies, but make the right choices depending on the situations. So this article interested me because Python and Node.js is something that I'm used to. So I wanted to read at it and find out why they immigrated, and also if they go into it, how. Why we migrated from Python to Node.js. It's a PR request that says fit, move the whole backend to Node. We just did something crazy. We completely rewrote our backend from Python to Node.js just 1 week after our launch. We did this so we can scale. Yes, scale, a week in. In some ways, it's a good time, right? The code base is still small and we don't have too many users. But on the other hand, it goes completely against the advice given to early stage startups, which is just to ship and sell and worry about scale once you've hit product market fit. Do things that don't scale, as PG put it. I think I agree with the sentiment that important thing is to ship, and I don't think that just goes for scale startups, but they also goes for solo developers too. I think we tend to worry a lot about technologies and how we set up things. We care about scalability, and all these are very important, but I think if we don't ship it, all these things don't really matter. But on the other hand, like it's written here, before the app grows too big, the best time to prepare for scaling is also now too. So I think it's a bit of a balance thing. You see, we didn't have a magical launch week that flooded us with users and forces us to scale. And generally, you can expect that any stack you pick should be able to scale reasonably well for a long time until you actually get to the point where you should consider changing frameworks or rewriting your backend in a different language. Read Rust. So why do it? Python async sucks. I'm a big fan of Django. I was introduced to it at postdoc, and it's become my go-to backend for most projects since. It gets you off the ground really fast, has great tooling and abstractions, and is still flexible enough to tweak to your needs. So naturally, when I started writing our backend at Scout, I started us off with Django too. Now we make a lot of calls to LLM and embedding APIs at Scout, so we are generally doing a lot of network I/O that we would like to be async. Not only that, we often want to fire a lot of requests concurrently, such as when we need to generate vector embeddings for the various chunks of a document. And things quickly got really messy in Django. I preface this by saying that neither of us has a lot of experience writing Python async code. I've mostly worked on async heavy services in Node, but I think this is partly the point here. It's really hard and unintuitive to write solid and performant Python async code. You need to go deep into the foundations of everything in order to be able to do so. I'm actually really interested in spending proper time in becoming more knowledgeable with Python async, but in our context, you lose precious time that you need to use to ship as an early stage startup, and B, can shoot yourself in the foot very easily in the process. So it sounds like they've made a choice to prepare for the scalability for the right reasons. I think if they were to keep the Django, it would have cost them more time because they would have looked into how to do it, whereas with Node.js they already know how to do it. In this case, I wonder why they didn't start with Node.js straight away. I guess the author really wanted to start with Django. Nevertheless, I thought I was to blame. Bad programmer was what I was hearing in my head as I tried to grasp everything. But while more knowledgeable folks would certainly have a better time, we discovered that the foundations of Python async are actually a bit shaky too. Unlike JavaScript, which had the event loop from the beginning, and Go, that created the concept of Go routines, both concurrency models that I quite like and have used in production. Python async support was patched on later, and that's where the difficulty lies. Two blog posts that cover this really well are Python has async for 10 years, why isn't it more popular? And Python concurrency, Go G event had it right. Both conveniently published not long before I started digging into all this. As for us, we learned a few things. Python doesn't have native async file I/O. Django still doesn't have a full async support. Async in the ORM is not done yet, and the colored functions problem really shines here. You can technically use Django with async, but their talks on this have so many caveats that it should scare anyone. You gotta write sync to async and async to sync everywhere. All sorts of models have emerged to bring better async support to different parts of the Python ecosystem, but as they are not native, they have their own caveats. For instance, AIO files brings async API compatible file operations but uses a thread pool under the hood. And G event with its greenlets is pretty cool, but it literally patches the standard stdlib in order to work. Due to a lot of async support in Python relying on layers that sit on top of the language rather than being native, you need to be careful about the async code you write, as it will have different implications depending on, for example, the GUnicorn worker type you run. Good luck learning much about those from the GUnicorn docs, by the way. Overall, just getting an equivalent of promise.o to work while understanding all of its gotchas was not simple at all. Faced with this, I went into the post-hoc codebase. I worked as post-hoc for 3 years, and we had no async in the Django codebase back then, but they are a massive company and they have AI features now, so they must have figured this out. And what I realized was that they are still running WSGE, not ASGE, with GUnicorn G-thread workers, where the max concurrent requests you are able to handle is usually max 4 CPU cores, thus not getting much benefit from running things async. The code base also has a lot of utils to make async work properly, like their own implementation of async to sync. So I guess way they are handling a lot of load is probably just horizontal scaling. There's simply no great way to run async in Django. Okay, now what? We essentially concluded that Django was going to hurt us really soon, not just when we started to have a lot of load. Without too many users, we would already need to start running multiple machines in order to not have terrible latency. Plus, we would be writing clunky code that would be hard to maintain. We could, of course, just do things that don't scale for now and just solve the problem with money or AWS credits, but it didn't feel right. And being so early would make the migration to another framework much easier. At this point, some people are probably screaming at their screens going, just use Fast API, and we did indeed consider it. Fast API does have proper async support and is quite a loved framework set to be performant. And if you want an ORM with it, if you could use a SQL Alchemy, which also supports async. Migrating to Fast API would have probably saved us a day or two. Our migration took 3 days due to being able to reuse a lot of code without translating it. But at this point, we weren't feeling great about the Python async ecosystem overall, and we had actually already written our background worker service in Node. So we thought it would be a good opportunity to go all in on one ecosystem. And so migrate to Node we did. We took a little time picking the framework and ORM combo, but settled to Express Micro ORM. And yeah, sure, Express is old, but it's battle tested and feels familiar. Coming over to the JS event loop was the main point of all this anyway. Yeah, I really wonder why they didn't start with Express in the first place, because I think that's something a lot of people are used to. JavaScript and Express, yeah, something a lot of people are used to, and it looks like the author has a lot of experience in it too. What we gained and what we lost. But it's really good to see that while JavaScript gets a lot of hate from a lot of users, it addresses these kind of problems. And Python is another popular language, and it addresses these kind of problems. And yeah, that's cool to see. And you can see why it's so widely used and why it's as popular as it is. What we gained, what we lost. Gained efficiency. Our initial benchmarks show we've gained 3 times throughput out of the box, and that's just with us running what is mostly sequential code in an async context. Being over on Node now, we are planning on doing a lot of concurrent processing when chunking, embedding, re-ranking, and so on. This means this change should have an even greater payoff over time. Lost Django. Losing Django hurts, and we've already found ourselves building a lot more middleware and utilities over on the Express side. Adonis exists, which is a more fully featured Node framework, but moving to a whole new ecosystem felt like more work to us than just using something minimal. What I'm missing the most is the ORM, which in my opinion is really ergonomic. And while you already always have to be careful with ORMs when looking to extract the best possible performance, the Django ORM does do some nice things under the hood in order to make it performant enough to write queries in Python. And I learned a bit more about this when migrating our Django models over to micro-ORM entities. Gained micro-ORM. Micro-ORM was a consolation prize in this whole migration. I still much prefer the Django ORM, but at the same time, different ecosystems call for different tooling. I had never used it before and was positively surprised to find Django like lazy loading, a migration setup that felt much better than Primus, as well as a reasonably ergonomic API once you manually set up the foundations right. Overall, we're early into this change, but currently happy to have picked micro-ORM over the incumbent Prisma. Lost. The Python ecosystem. I think this is pretty self-explanatory. While most tools building regs and agents have Python and TypeScript SDKs, Python still takes priority, and we are just talking about API wrappers here. Once you want actually get into ML stuff yourself, there's just no competition. I suspect that we get more sophisticated and we'll end up having a Python service, but for now we are okay. Okay, so they are actually, I didn't even read where the article was coming from, but it's coming from Yako Majiri, and it looks like it's a AI ML app, and yeah, I mean, when I worked as data science, I used Python and Julia mainly. So yeah, Python has just these libraries that's just, yeah, it's just the industry standard for AI ML, I guess. Gained unified code base. We had always realized that migrating to Node would mean we would have 2 Node services instead of a Python one and a Node one. But it didn't occur to us until a day in that we could actually merge the code bases, and that would be extremely helpful. There was a lot of duplicate logic across the Node worker and the Django server, and now we've unified the Express server and background worker into one code base, which feels so much better. They can both use the ORM now. Previously, the worker was running raw SQL and share a bunch of utils. Do you guys say SQL or SQL? For me, I say SQL, although I read that as SQL. Gained much better testing. This is not a PyTest versus Jest thing. It's just that in order to make sure everything was working as expected after migrating, we just wrote a ton more tests. This and some refactoring were welcome side benefits. How we did it. I think it's about time to wrap this post up, but here are some quick notes about the actual migration process. I'm keen to read this. It took us 3 days. 3 full days. I wonder how many people was involved in it. We barely used AI code generation at all until the final bits. It felt important for us to understand the foundations of our new setup really well, particularly the inner workings of the new ORM. Once we had the foundations of everything down, Cloud Code was quite helpful in generating code for some less important endpoints, and also helped us in scanning the code base for issues. I think it's always worth knowing your code base really well, so that if there are any problems, it's so easy to edit. And if you want to scale, you can scale. We almost quit multiple times. We were getting customer requests for new features and had some bugs in the Django code, and it felt like we were wasting time migrating instead of serving customers. Would we do it again? Honestly, we're quite happy with our decision and would 100% do it again. Not only this pay off in the long term, but it's already paying off today. We learned a lot of stuff in the process too, and if the whole point of this whole post is that someone comes to tell me that we are dumb and we should just have done X or Y, or comes to teach me about how Python async works, then that will honestly be great. For my part, I gladly recognize my inexperience with Python async, and if I can learn more about it, that's a win. And if you're interested in actually seeing the code, check out the following pull requests. Oh, that pull request was actually real, featuring moved the whole backend to the node. But I think the issue with this, but wouldn't this pull request be super big? And I've always been told that the best practice is to make smaller pull requests rather than small incremental pull requests rather than big pull requests. So I'm thinking, why not have the Python start migrating one by one or something like that? Not sure. Scout is an MIT licensed Reg API platform, so if you have any thoughts or concerns, you can come yell at us on GitHub or open a PR to rewrite the backend to your framework of choice. Yeah, but interesting insight, interesting article. I hope you enjoyed that. I like both of those technologies, so I feel like my comments are very unbiased. But thank you guys for watching. I'll see you in the next one. Like and subscribe. Bye.